Take a deep, slow breath in and let your body settle completely into the soft support beneath you. Release the tension in your shoulders, allowing the quiet of the night to wrap around you like a heavy, comforting blanket. Right now, inside the comforting void of your mind, a vast cosmic network is at work. The human brain contains roughly 86 billion neurons, a number remarkably similar to the estimated number of stars in our Milky Way galaxy. When you sit down to partake in the peaceful ritual of journaling, you are initiating a highly complex physical and chemical transfer of energy from this inner universe to the outer world. The simple, quiet urge to write an idea down sends electrical impulses cascading down your motor neurons at astonishing speeds of up to 120 meters per second, or roughly 268 miles per hour. Yet, despite this blinding internal speed, the outward expression is one of profound stillness and grace. As you imagine picking up a pen or a pencil, consider the breathtaking biological machinery required simply to hold it. The average human hand is a marvel of evolutionary engineering, containing exactly 27 bones, 27 joints, and 34 individual muscles. All of these biological components work in a highly synchronized, silent micromanagement to form a single, sweeping letter on a page. It is a slow, deliberate choreography that bridges the gap between thought and physical matter. When the tip of a graphite pencil meets the surface of a notebook, a microscopic dance of physics begins. The friction coefficient between a standard graphite core and paper is roughly 0.5. This specific, mathematically predictable measurement is precisely what creates the soft, rhythmic resistance we feel, a gentle, satisfying drag that allows for precise motor control without slipping. It is a tactile feedback loop, grounding you in the physical present. And what is that graphite leaving behind in its wake? It is pure carbon, arranged in microscopic, perfectly hexagonal lattices. Carbon is the fourth most abundant element in the entire universe. It is not native to Earth. Rather, it was forged billions of years ago in the extreme, crushing heat and pressure of ancient dying stars. When you drag a pencil across a page, you are literally smearing stardust into shapes, letters, and symbols. You are capturing your fleeting, transient thoughts in a medium born from the deep cosmos. Through the simple act of journaling, you become the universe, quietly recording its own inner dialogue. Beneath your writing instrument lies the paper itself, a landscape of hidden textures and ancient light. Typical writing paper has an incredibly fine thickness of about 50 to 100 micrometers, or 0.05 to 0.10 millimeters. Yet, if you were to look at it under a microscope, you would see a complex, interwoven forest of fibers. Paper is composed primarily of cellulose, an organic compound with the chemical formula C6H10O5 taken to the power of N, representing its long, durable polymer chains. This cellulose was built by living plants using the process of photosynthesis. This means that every single page in your journal is essentially woven from captured sunlight and atmospheric carbon dioxide. You are writing on the physical memory of a sunbeam set. If you choose a pen instead of a pencil, you engage different, equally fascinating laws of fluid dynamics and physics. Consider the standard ballpoint pen resting in your hand. The viscoelasticity of the ink dictates exactly how smoothly it flows onto the page. To overcome the ink's resting viscosity, your hand naturally applies a downward pressure of around 150 to 500 grams. This gentle, comforting weight presses a microscopic sphere, often a tiny 1 millimeter ball made of incredibly dense tungsten carbide, against the page. As it rolls over the woven cellulose, it dispenses the ink in a perfect continuous ribbon. The paper then absorbs this liquid through a process known as capillary action. The intermolecular forces between the ink and the microscopic plant fibers pull the moisture inward, drying the words in a matter of milliseconds. It is a quiet, seamless chemical bonding taking place right beneath your fingertips, locking your memories into the physical world. Focus for a moment on the sensory experience, the subtle sounds of this ritual. The quiet scratching of a nib or a pencil point moving across paper produces acoustic frequencies, typically hovering between 2,000 and 5,000 hertz. This specific auditory range is deeply soothing to the human nervous system. In fact, it is the exact frequency range often associated with triggering the deep relaxation and physical tingling of autonomous sensory meridian response, or ASMR. The rhythmic sweeping noise of writing acts as a metronome for a restless mind, a gentle acoustic anchor that holds your awareness safely in the present moment, far away from the anxieties of the day. And then there is the scent. The olfactory system in your brain is intimately and biologically tied to the hippocampus, the center for memory formation. When you open a well-loved journal, especially one with slightly aged pages, you are greeted by a distinct, comforting aroma. This smell is the direct result of the slow chemical breakdown of cellulose and a natural plant-binding polymer called lignin. Over time, as paper ages, it releases volatile organic compounds into the ambient air. Among these compounds are benzaldehyde, which carries a faint, warm scent of almonds, and vanillin, the exact same chemical compound that gives natural vanilla extract its sweet, calming aroma. Breathing in the scent of an old journal is literally breathing in the gentle, sweet chemistry of time passing. Let us drift deeper into the neuroscience of this quiet hour to understand why the physical act of writing brings us such profound, sedative peace. In 1956, a cognitive psychologist established a foundational principle known as Miller's Law. This law states that the average human working memory can only hold roughly 7 items, plus or minus 2, at any given moment. When your mind feels overly full, scattered, or overwhelmed late at night, it is often because you are pushing the absolute biological limits of your working memory. A journal acts as an infinite external hard drive. By transferring your thoughts onto paper, you bypass Miller's Law entirely, safely offloading the cognitive burden and creating vast, quiet spaces within your conscious mind. This feeling of mental release is a heavily studied and recognized psychological phenomenon. It is closely related to the Zeigarnik effect, a principle that describes the human brain's tendency to fixate on uncompleted tasks, keeping them actively circulating in your thoughts and preventing sleep. Writing down what you need to do tomorrow or what you are worried about tonight effectively closes these open cognitive loops. The brain registers the physical, visual act of documentation as a form of completion, finally allowing the mental gears to disengage, slow down, and rest. When you use your journal to explore your emotions, something even more profound occurs within your neural pathways. In a fascinating 2007 neurological study by researcher Matthew Lieberman, scientists observed a process called affect labeling. When subjects translated their abstract emotional experiences into concrete, written words, functional MRI brain scans showed a significant reduction in the activity of the amygdala, the brain's ancient emotional processing and fear center. At the exact same time, neurological activity increased in the right ventrolateral prefrontal cortex, a modern brain region associated with logic, reasoning, and emotional regulation. In the simplest, most beautiful terms, the physical act of writing transforms chaotic feelings into structured, manageable data. It literally cools the emotional temperature of the brain, extinguishing the fires of anxiety. This calming, cooling effect is naturally enhanced by the sheer, unhurried mechanics of handwriting. A 2014 study by psychological researchers Miller and Oppenheimer found that while most adults can type on a keyboard at frantic speeds of 40 to 50 words per minute, writing by hand slows us down to an average of just 15 to 20 words per minute. This physical limitation is not a flaw of the medium. It is its greatest, most comforting feature. Because you cannot write as fast as you think, your brain is forced to process, filter, and gently summarize the information before the pen even touches the paper. This deliberate deceleration naturally brings your breathing down to a steady, rhythmic pace. It invites a state of profound mindfulness, tying the rapid speed of your neurons to the slow, heavy physical capabilities of your hands. The ripples of this quiet, nightly ritual spread outward, echoing throughout your entire physical body. A foundational 2005 study conducted by Bakey and Wilhelm demonstrated that engaging in expressive writing for just 15 to 20 minutes a day over a short period produces measurable, deeply restorative physiological benefits. It has been proven to lower blood pressure, improve immune system functionality, and even enhance liver function. The simple act of sitting in a quiet room, bathed in soft, warm light, reflecting on the pages before you, sends a powerful signal to your parasympathetic nervous system. It tells your ancient biology that you are safe from harm. It tells your body that the day's vast journey is complete and the time for cellular repair has begun. As the ink sets into the microscopic plant fibers and the cover of the book is gently closed, the transition from waking life into the deep sleep of the cosmos becomes seamless. Clinical sleep studies have shown that writing in a journal just before bed significantly decreases cognitive arousal, effectively reducing sleep latency, the time it takes for you to fall asleep, by up to 9 full minutes. Your mind, now emptied of its burdens, poured safely onto the starlight-derived cellulose pages, is finally free to drift. The heavy lifting has been done. The data of your day has been recorded, measured, and stored in the physical universe. Feel the profound weightlessness of a mind completely unburdened. Let the physical world of paper, carbon stardust, and tungsten carbide gently fade into the background, leaving only the tranquil, slow-moving echo of your peaceful thoughts. As the modern pen rests quietly on the cellulose, we are participating in a slow, a rhythmic tradition that stretches back across thousands of planetary orbits around our local star. The urge to record, to stabilize the fleeting electricity of human thought into physical matter, is a cosmic imperative that has defined our species for millennia. Around 3,400 BCE, in the ancient cradle of Sumer located in Mesopotamia, humans first engineered a way to externally store their memory, developing the earliest known writing system called cuneiform. They achieved this by pressing wedge-shaped reeds into damp tablets of clay. Clay itself is a geological marvel, composed primarily of hydrous aluminum phyllosilicates. Its chemical formula, Al2O3.2, SiO2.2, H2O, represents a crystalline structure forged deep within the Earth's crust over eons. These specific silicate minerals are the literal descendants of stardust, formed from the primordial accretion disk that birthed our entire solar system 4.6 billion years ago. When an ancient Sumerian pressed a stylus into a clay tablet, They were carving their daily records into the condensed ashes of the early universe. Shortly after, around 3000 BCE, alongside the slow-moving currents of the Nile River, ancient Egyptians began harvesting a tall aquatic sedge known scientifically as Cyperus papyrus. By slicing the pith of this plant into thin strips, soaking them, and pressing them together, they created the world's first flexible writing surface. The preservation of these early human records often relied on the incredibly dry, stable atmospheric pressure of the desert environment. Notice how the desire to preserve thought pushes us to utilize the most enduring materials available. The famous Rosetta Stone, inscribed in 196 BCE, allowed modern linguists to finally decode Egyptian hieroglyphs. It was not carved into soft stone, but rather into granodiorite. Granodiorite is an intrusive igneous rock, formed when silica-rich magma cools very slowly, deep beneath the Earth's surface, over millions of years. This slow cooling process allows large, durable interlocking crystals of quartz and feldspar to grow, creating a medium capable of holding a message through centuries of erosion. Think of a journal as a temporal telescope. In astronomy, when we observe distant celestial bodies, we are looking backward in time. Because light travels at a finite speed of 299,792 kilometers per second, the photons from the Andromeda Galaxy take 2.5 million years to reach our retinas. We see the galaxy exactly as it was millions of years ago. Similarly, ink on a page transmits human consciousness across the vast, silent distances of time. When you read a historical diary, the thoughts arrive intact in your mind, completing a journey that began centuries earlier. Between the years 170 and 180 CE, the Roman Emperor Marcus Aurelius engaged in a nightly ritual of documenting his philosophical reflections while on military campaigns. His text, which we now know as Meditations, was originally titled in Greek as Ta eis Heauton, which directly translates to himself. This document is widely recognized by historians and psychologists as the first major recorded instance of cognitive behavioral therapy. Aurelius was instinctively using the slow, deliberate act of writing to regulate his emotional state, in anchoring his mind against the chaotic tides of the Roman Empire. The word journal itself carries the rhythmic cycle of the Earth's rotation in its very etymology. It originates from the 14th century Old French word, journal, meaning daily, which in turn is derived from the Latin diurnalis. It is a word intrinsically tied to the 24-hour cycle of our planet, turning on its axis, bringing the alternating comfort of sunlight and the restorative shadow of night. Deep within the Han Dynasty of China, around the year 105 CE, an official named Kai Lun revolutionized this daily practice by inventing the first true modern paper-making process. He macerated the inner bark of the mulberry tree, along with hemp and textile rags, suspending the cellulose fibers in water before draining them flat. Thus, this precise botanical chemistry created a lightweight, highly durable surface that eventually swept across the globe, quietly replacing heavy parchment and brittle papyrus. By the time the Middle Ages arrived in Europe, the primary vehicle for recording thoughts had evolved into iron gall ink, which remained the standard writing fluid from the 5th century all the way through the 19th century. The chemistry of iron gall ink is a beautiful slow-motion reaction. It was crafted by extracting tannic acid from oak galls, small round growths found on oak trees, and mixing it with iron 2 sulfate, historically known as copperas. When this liquid mixture first touches the page, it is a pale, faint gray. But as it is exposed to atmospheric oxygen, a slow oxidation process occurs, darkening the ink into a deep, permanent purplish black. Consider the profound cosmic origin of that iron. Iron is the absolute terminal element of stellar nucleosynthesis. Inside the core of a massive star, immense gravitational pressure fuses lighter elements together. Hydrogen into helium, helium into carbon, carbon into oxygen, all the way up the periodic table. But when a star begins to fuse silicon into iron, the reaction no longer releases energy, it absorbs it. Once a star accumulates a core of pure iron, the delicate billions of years old balance between gravity pulling inward and nuclear fusion pushing outward is abruptly broken. The star collapses in a fraction of a second, resulting in a magnificent supernova explosion that scatters that iron across the galactic void. When medieval scholars and Renaissance thinkers dipped their pens into iron gall ink, they were literally drawing with the pulverized remnants of collapsed stars. To apply this cosmic ink to paper, humanity turned to the biology of flight. Quills were introduced into wide circulation around the 6th century CE. Scribes preferred the primary flight feathers of large molting birds, such as geese or swans. Feathers are composed entirely of alpha-keratin, a highly resilient structural protein. At the microscopic level, alpha-keratin consists of long polypeptide chains that coil into right-handed alpha helices. These helices then twist together to form incredibly strong, stiff, yet flexible microfibrils. It is this exact molecular geometry that allowed a quill to hold a perfect reservoir of ink while bending gracefully under the gentle pressure of a writer's hand. Scientists discovered that the tactile experience of journaling shifted dramatically in the year 1564, following the unearthing of a massive, pure graphite deposit in the Borrowdale parish of England. Unlike the scratchy friction of a quill, graphite offered a silent, deeply smooth glide across the page. Because pure graphite consists of carbon atoms arranged in flat, loosely stacked planar layers, these microscopic sheets easily slide past one another. The van der Waals forces holding the layers together are remarkably weak, allowing the stardust-forged carbon to shear off effortlessly onto the textured cellulose. Picture the candlelit study of Samuel Pepys, who maintained one of the most famous and historically significant diaries in the English language from 1660 to 1669. Over the course of those 9 years, he recording the quiet details of his daily life alongside massive historical events, Pepys wrote over 1 million words. To achieve the necessary speed and privacy for his thoughts, he utilized a complex early system of shorthand called tachygraphy, invented by Thomas Shelton. This cryptographic method condensed complex phonetic sounds into simple sweeping geometric symbols, minimizing the physical distance the hand had to travel and allowing his external record to keep pace with the rapid firing of his synapses. What is happening now, when we write with modern instruments, is the culmination of centuries of fluid dynamics research. In 1884, an inventor named Lewis Waterman patented the first highly practical fountain pen. He solved the ancient problem of ink blotting by engineering a feed system that utilized capillary action. By cutting 3 microscopic, mathematically precise grooves into the hard rubber feed beneath the nib, Waterman allowed air to slowly enter the ink reservoir at the exact same volume and rate that the ink flowed out. This equalization of atmospheric pressure created a continuous, reliable flow of liquid, turning the act of writing into a seamless, uninterrupted meditation. We are able to accurately measure the vast timeline of these historical journals through a process deeply connected to our atmosphere. Radiocarbon dating relies on the presence of carbon-14. At this very moment, high-energy cosmic rays, traveling through the freezing vacuum of space at nearly the speed of light, are constantly bombarding our upper atmosphere. When these rays collide with nitrogen atoms, they create carbon-14, a radioactive isotope that is absorbed by all living plants, including the papyrus, hemp, and trees used for paper. Carbon-14 decays at a strictly predictable rate, possessing a half-life of precisely 5,730 years. By measuring the remaining radiation in the cellulose of ancient texts, such as the Dead Sea Scrolls, which date back between the 3rd century BCE and the 1st century CE, physicists can calculate exactly when the plant was harvested. The quiet, solitary act of writing a thought down leaves a measurable mathematical footprint that survives for millennia. As we look back at the long, slow march of historical time, from the wet clay of Mesopotamia to the precision-machined pens of the modern era, the underlying ritual remains entirely unchanged. The tools are merely different configurations of earth, metal, and starlight. The true constant is the quiet atmospheric peace found in the translation of an invisible thought into a visible, enduring reality. As the ink settles into the woven cellulose, look closely at the quiet illumination of your desk space. The gentle light from a solitary lamp travels downward in a continuous, silent stream of massless particles called photons. These tiny packets of energy carry electromagnetic radiation within the visible spectrum, specifically vibrating at wavelengths between 380 and 700 nanometers. When these photons strike the blank pages of your journal, they encounter the bleached plant fibers. Much like a mirror effortlessly bouncing a sunbeam across a room, the bright white paper reflects nearly 100% of this visible light back toward your eyes. The dark ink, however, behaves in an entirely different manner. Black pigment is a master of thermal and optical absorption, capturing all visible wavelengths of light that hit it. Think of the freshly written letters on your page as microscopic black holes, quietly swallowing the ambient light of the room. A journal is essentially a passive cinema screen, where the shape of your thoughts is made visible, not by the presence of light, but by its precise, intentional absence. Between your eyes and the paper exists a bustling, invisible ocean. We often think of the room around us as empty space, but it is actually a thick, dynamic fluid composed of exactly 78% nitrogen gas and 21% oxygen gas. At a standard room temperature, these atmospheric molecules are zipping through the air at blistering speeds of roughly 500 meters per second. Imagine millions of invisible, microscopic billiard balls constantly colliding in a perfectly elastic, silent dance around your pen. Yet, you feel nothing but a gentle stillness. The atmospheric pressure they exert on your skin and the open notebook is approximately 14.7 pounds per square inch. It is a steady, comforting embrace, an invisible atmospheric blanket holding your journal securely to the surface of the desk. Look deeply at the modern gel pen, resting between your fingers. The fluid inside the plastic barrel exists in a fascinating state of suspended animation. It is scientifically classified as a thixotropic fluid. This means that when the pen is at rest, complex molecular polymers interlock, holding the ink together as a thick, semi-solid gel. But the precise moment the 1 millimeter ball at the tip rolls against the paper, the friction applies a specific shearing force. Instantaneously, the gel's viscosity plummets, and it transforms into a free-flowing liquid. This non-Newtonian physics is identical to the mechanics of ketchup resting in a glass bottle. It remains stubbornly solid until physically agitated, at which point it yields and flows with sudden, satisfying grace. Suspended within this gel, are billions of individual pigment particles, each measuring between 0.1 and 2 micrometers in diameter. To put that microscopic scale into perspective, a single pigment particle is roughly the size of a common, single-celled bacterium. Because they are significantly larger than the easily dissolved molecules used in traditional dye-based inks, these pigments do not sink deep into the porous paper. Instead, they sit right on the surface of the paper fibers, while like smooth river stones resting on a solid bank, perfectly preserving the crisp, sharp geometry of your handwriting against the slow erosion of time. As those microscopic stones of ink are laid down, your physical body reads the microscopic terrain. Just beneath the outer layer of skin on your fingertips lie specialized nerve endings called Pacinian corpuscles. You possess around 3,000 of these tiny onion-shaped sensors in every square inch of your hand. They are biologically engineered to detect high-frequency vibrations. When your pen glides across the subtle ridges of the paper, it generates tiny acoustic tremors. Your Pacinian corpuscles are so exquisitely tuned that they can register surface deviations as minuscule as 10 nanometers. In essence, your fingers operate exactly like a highly sensitive geological seismograph, reading the invisible rhythmic earthquakes caused by a pen dragging across paper, translating that texture directly into a feeling of comfort. Notice the temperature of the paper beneath your resting wrist. Unlike a steel desk or a glass table, which instantly pulls heat away from your skin, the pages feel uniquely neutral, perhaps even slightly warm. This is a direct result of paper's specific heat capacity, which measures approximately 1.4 joules per gram per degree Celsius. Cellulose is a natural thermal insulator. It absorbs your body heat very slowly, holding on to the temperature in much the same way a dry, fallen autumn leaf warms up softly when cupped in the palm of your hand. This thermal harmony between human skin and plant fiber makes the physical environment of journaling feel inherently safe and inviting. While you review the words you have just documented, your eyes perform a mechanical marvel. They do not glide smoothly across a line of text, even though it feels as though they do. Instead, the human eye executes rapid, ballistic jumps, known scientifically as saccades. Each saccade takes a mere 20 to 200 milliseconds to complete. Between these lightning-fast jumps, your eyes lock onto a cluster of letters in a pause called a fixation, lasting for 200 to 300 milliseconds. It is only during these momentary pauses that your optical nerve actually transmits visual information to the brain. Reading your own journal is perfectly comparable to an old-fashioned film projector, flashing individual static frames on a screen at high speed. Your visual cortex flawlessly stitches these fragmented, millisecond snapshots together into a smooth, continuous narrative reality. During this visual dance, the electrical rhythm of your brain undergoes a fundamental and restorative shift. Throughout the active problem-solving hours of the day, your brain operates primarily in a beta wave state, characterized by rapid electrical oscillations ranging from 12 to 38 hertz. But as you engage in the slow, rhythmic repetition of handwriting, your visual cortex and motor regions synchronize. The frequency of your neural oscillations gently drops into the alpha wave state, measuring a steady rolling 8 to 12 hertz. This precise electrical frequency is identical to the brain state you experience when you close your eyes and listen to the rhythmic, unbroken sound of rain falling against a window pane. It is the exact neurological signature of peaceful wakefulness, a natural biological sedative. Step back from the desk for a moment and consider the macroscopic rhythms carrying you through this process. If you sit quietly and write for just 20 minutes, an astonishing cosmic motion takes place. In that brief window of time, the Earth rotates exactly 5 degrees on its planetary axis. If you happen to be located near the equator, the rocky surface of the planet is physically carrying you eastward at a velocity of roughly 1,000 miles per hour. You are currently traveling faster than the speed of sound, seated comfortably within a perfectly silent, unimaginably massive spacecraft, orbiting a burning star. Yet, the massive pull of gravity and the shared momentum of the atmosphere hold you so perfectly in equilibrium that the ink in your pen never wavers, and the tea in your mug barely registers a ripple. The universe spins at dizzying and terrifying speeds, but from your perspective at the desk, it offers only perfect, unyielding stability. Even the physical binding that holds your journal together is a testament to the elegant physics of tension. Many high-quality notebooks employ a traditional technique called Smith sewing, where groups of folded pages, known as signatures, are stitched together through the fold. The specialized cotton or synthetic thread used in this binding typically holds a tensile strength of about 4 to 5 kilograms. This means the thin, barely visible strings organizing your memories can support the weight of a heavy stone before snapping. Like the invisible gravitational forces keeping the moon locked in a stable orbit around the Earth, these simple, unseen threads exert a quiet, continuous pull. They ensure that the architecture of your thoughts, the chronological record of your days, remains securely bound together in the comforting void of the night. Look closely at a shelf in your room, perhaps the quiet corner, where you store your completed notebooks. When you slide a finished journal into its resting place, you are not merely putting away a book. You are archiving a highly precise biological and psychological cross-section of your existence. Over a lifetime, the pages you fill become a macroscopic timeline, capturing the slow gravitational orbit of your personal history. Think about the architecture of the paper waiting for you on that shelf. Historically, standard wood pulp paper was prone to a destructive chemical process known as acid hydrolysis. The natural lignin within the wood would react with ambient moisture, creating acids that slowly broke down the cellulose polymers, turning pages brittle and yellow within a few decades. However, modern high-quality journals often use what is scientifically classified as archival-grade, acid-free paper. During the manufacturing process of this specialized paper, an alkaline buffer is intentionally introduced into the pulp. This buffer is almost always calcium carbonate, a chemical compound with the formula CaCO3. This specific compound holds a profound cosmic and planetary heritage. Calcium carbonate is the exact same biological building block that comprises the shells of ancient marine organisms, the vast chalk cliffs of Dover, and the slow-growing architecture of the world's coral reefs. When a manufacturer embeds this mineral into your notebook, chanting, they are giving the paper the capacity to resist atmospheric acidity. Because of this microscopic calcium shielding, an acid-free journal can survive for over 1,000 years without crumbling. In a very real sense, your journal is a dry, slow-growing coral reef of human consciousness, built layer by layer, fortified by the ancient oceans of the Earth, capable of outlasting civilizations. As you run your hand across a page, you are leaving behind far more than just ink. The human body is a continuously regenerating organism. Biologists have calculated that the average adult sheds roughly 200 million dead skin cells every single hour. These microscopic, flattened discs, known as squamous cells, measure approximately 30 micrometers in diameter. As you sit at your desk, breathing deeply and leaning over your notebook, Thousands of these cells quietly drift downward, embedding themselves permanently between the woven plant fibers of the paper. Locked within the nucleus of those shed cells is your complete genetic code. In 2012, paleogeneticists calculated that under ideal, stable environmental conditions, DNA has a half-life of exactly 521 years. This means that an old journal is not just a metaphorical extension of your mind. It is a literal, biological time capsule. You are physically woven into the stratigraphy of the book. Centuries from now, the paper will still hold the microscopic, chemical truth of your physical presence on this planet. To understand why this external storage is so vital to your daily life, we must look at the mathematical limits of human recall. In 1885, Chaikin, a pioneering German psychologist named Hermann Ebbinghaus, conducted a series of rigorous experiments that resulted in the discovery of the Ebbinghaus forgetting curve. Through careful measurement, he proved that the human brain naturally discards approximately 70% of all newly acquired information within just 24 hours. The brilliant, vivid details of an ordinary Tuesday, the precise shade of the sky, the exact phrasing of a conversation, the fleeting warmth of a moment, are biologically programmed to evaporate, swept away to conserve neural energy. When you sit down to write, you are actively defying this natural law of cognitive decay. A journal halts the Ebbinghaus forgetting curve in its tracks. By externalizing your experiences into physical shapes on a page, you trap the fleeting electricity of the present moment, preserving it against the relentless, eroding tide of time. What occurs when you eventually open an older journal to read your past words is a marvel of neurobiology. The simple act of retrospective reflection deeply engages a specific web of brain regions known as the default mode network, or DMN. The DMN becomes highly active whenever we step away from immediate external tasks and turn our attention inward, toward daydreaming, envisioning the future, or recalling our past. Although it operates quietly in the background, this network is incredibly resource-intensive, consuming roughly 20% of your body's entire resting energy. As your eyes scan your own handwriting from years ago, your default mode network essentially runs a high-fidelity neurological simulation, reconstructing the sensory reality of your past self. You are able to sit comfortably in the quiet of the night, yet mentally time travel back to the exact atmospheric conditions of a memory. Notice how the physical shape of your handwriting changes and evolves over the years. Your signature and your script are a highly distinct biomechanical fingerprint created by a complex neuromuscular loop that no one else on Earth possesses. This fluid motion is heavily managed by the cerebellum, a remarkable structure situated at the base of your skull. Even though the cerebellum accounts for only about 10% of the brain's total volume, it contains roughly 50% of the brain's total neurons. It is a hyperdense supercomputer dedicated entirely to coordinating smooth, precise, habitual movements. A fascinating 2020 study conducted by neuroscientists at the Norwegian University of Science and Technology mapped this exact phenomenon. Using high-density electroencephalograms, or EEGs, equipped with 256 individual sensors, the researchers monitored the electrical activity of the brain while subjects wrote by hand. They discovered that the continuous, looping physical movement of cursive writing actively generates synchronized brain waves in the theta range, which oscillates between 4 and 8 Hz. Theta waves are deeply associated with profound learning, memory consolidation, and the twilight state, right between wakefulness and sleep. The continuous physical geometry of writing in a journal literally tunes your brain's frequency into a highly receptive, deeply peaceful state of flow. Typing on a glass screen or a mechanical keyboard does not produce this same harmonious, rolling electrical wave. Protecting this biological and psychological record requires an alliance with the shadows. When you close a notebook and place it in a drawer or on a shelf, you are engaging in a crucial act of chemical preservation. Ambient sunlight contains ultraviolet radiation, consisting of high-energy electromagnetic waves measuring between 10 and 400 nanometers in length. If left exposed, these UV photons possess enough kinetic energy to smash into the chemical bonds of dyes and pigments, a process known as photodegradation. The photons excite the electrons within the ink's molecules, causing the complex bonds to snap, which results in the slow fading and bleaching of the color. However, many high-quality archival pens use a formulation derived from ancient India ink, which utilizes pure carbon black as its primary pigment. Carbon black is essentially pure microscopic soot. Because carbon is one of the most chemically stable and inert elements in the universe, it does not easily react to light, heat, or atmospheric oxygen. It simply ignores the chaotic energy of the environment. When you write with carbon-pigmented ink and close the cover of your journal, the words enter a state of total suspended animation. In the dark, quiet space of a closed book, the carbon atoms remain utterly motionless, holding the exact shape of your joy, your worries, and your dreams, completely undisturbed by the passing of decades. Imagine the deep, profound comfort of knowing that your life is safely documented. In the overwhelming rush of modern existence, the endless stream of data, the temporary anxieties of the week, they do not have to be carried internally anymore. You have transferred that weight to the calcium carbonate and the stardust. You have entrusted your memories to the heavy, silent physics of the physical world. Your journal stands as a quiet monument to your personal journey, an anchor holding your narrative steady against the spinning rotation of the Earth. The universe is incredibly vast, stretching out for billions of light years in every direction. Yet within the bound pages on your desk, you have created a perfectly ordered, entirely safe pocket of space and time. A place where nothing is lost, nothing is forgotten, and everything is waiting peacefully for your return. Deep within the mechanics of human vision, the way we perceive the stark contrast of ink on a page is entirely dependent on specialized photoreceptor cells located at the very back of our retinas. When you gaze at a well-lit journal entry, you are relying primarily on cones. The human eye typically contains about 6 million of these cone cells, which are highly concentrated in the fovea centralis, a tiny pit in the macula, responsible for sharp, detailed central vision. These cones require a significant amount of ambient light to function correctly. However, as the evening draws to a close and you rely on the softer ambient glow of a bedside lamp, a subtle biological shift occurs. Your vision begins to transition its workload over to the rods. The retina contains roughly 120 million rod cells, vastly outnumbering the cones. Rods are incredibly sensitive to low levels of light, capable of responding to a single photon, but they do not process color. Instead, they interpret the world purely in shades of gray. This phenomenon, known as the Purkinje shift, explains why the deep blue ink of a pen or the vibrant red cover of a notebook seems to slowly mute and cool down as the room darkens. The vibrant hues of the day fade away, leaving only a soft monochromatic calmness that gently prepares your optic nerve for the darkness of sleep. Think about the physical weight of a substantial leather-bound diary resting quietly on your lap. That feeling of comforting gravity is the direct result of a highly specific tanning process that alters the fundamental molecular structure of animal hide. The leather binding is created by utilizing tannins, naturally occurring, astringent polyphenolic biomolecules found abundantly in tree bark, particularly from the quebracho, chestnut, and oak trees. When animal skin is steeped in a tannin-rich solution, these complex organic compounds bind deeply to the collagen proteins. Collagen itself is a remarkable triple helix of amino acids, tightly wound together to form strong structural fibrils. The tannins displace water molecules and lock these collagen fibers in place, transforming a rapidly decaying organic material into an incredibly durable, flexible, and chemically stable book cover. This transformation gives leather its distinct heavy density and its deeply evocative scent. The complex olfactory profile of leather is primarily composed of volatile organic compounds such as nonanal and octanol. When these specific aldehydes vaporize into the air around you, they are drawn into your nasal cavity and immediately bind to your olfactory receptors. Unlike other sensory pathways, your olfactory bulb routes these chemical signals directly to the limbic system, the oldest, most primitive sector of the brain, heavily involved in emotional processing and long-term memory formation. This is precisely why the rich, earthy scent of a leather journal can instantly evoke feelings of safety, antiquity, and warmth, completely bypassing conscious thought to deliver a direct, chemical message of comfort. Observe how the pages inside that binding react to the environment. If you leave a journal open near a window on a humid evening, the paper will subtly buckle and wave. This is not a flaw. It is a demonstration of hygroscopy. Cellulose, the primary botanical polymer in paper, is highly hydrophilic, meaning it naturally attracts and holds on to water molecules from the surrounding air. At a standard room humidity of 50%, a sheet of typical writing paper is composed of roughly 5 to 7% water by total weight. When the atmospheric humidity rises, the cellulose fibers absorb the excess microscopic water vapor. Because hydrogen bonds form between the water and the hydroxyl groups in the cellulose, the individual plant fibers physically swell, expanding laterally. The paper literally breathes in the moisture of the room, growing slightly wider and causing the page to warp. It is a slow, silent interaction between the atmosphere and the physical record of your thoughts. Your journal is actively participating in the Earth's local water cycle. Even the humble eraser sitting next to your notebook operates on fascinating principles of adhesion and polymer physics. If you make a mark with a graphite pencil, you are laying down a very thin, dusty layer of carbon. When you use a standard pink rubber eraser, which is typically composed of synthetic rubber, like styrene butadiene, mixed with pumice, you are creating targeted friction. The kinetic energy of your hand rubbing the eraser against the paper generates localized heat. This warmth causes the synthetic rubber to become temporarily sticky, increasing its tackiness. Because graphite particles have a stronger affinity for the sticky polymer of the eraser than they do for the woven cellulose of the paper, the carbon stardust literally jumps off the page and embeds itself into the rubber. The pumice acts as a micro-abrasive, gently scraping away the very top microscopic layer of paper fibers to ensure all the graphite is captured. The resulting soft gray crumbs you sweep away are tiny bundles of captured mistakes, physically removed from your permanent record through the elegant laws of thermodynamics and adhesion. If you prefer to write with a classic wooden pencil, you are interacting with a very specific, carefully selected species of tree. The vast majority of high-quality pencils in the world are manufactured from incense cedar, scientifically known as Calocedrus decurrens. This particular species of conifer, native to the mountainous regions of western North America, is chosen for its perfect anatomical consistency. The wood has a highly uniform, straight grain, meaning the long vertical cells of the tree grow in perfectly parallel lines. Furthermore, incense cedar possesses an unusually low concentration of hard resins and knots. When you run a metal sharpener around the wood, the steel blade easily slices across those uniform cells, producing a smooth, continuous ribbon of shavings rather than jagged splinters. The blade creates a perfectly conical point, mathematically optimized to distribute the pressure of your hand evenly down to the graphite core. As you sharpen the pencil, the broken cells of the cedar release their natural aromatic oils, filling the air with that sharp, clean, nostalgic scent. It is a sensory ritual that relies entirely on the precise, evolutionary biology of a distant forest. Consider the microscopic chemistry happening when you cap a modern gel pen. The click of the plastic lid is not just a satisfying sound. It is an essential, airtight seal. Gel inks contain a high percentage of water, often up to 80%, acting as the primary solvent that carries the heavy pigments. If left exposed to the ambient atmosphere, this water would rapidly evaporate. The rate of evaporation is governed by the vapor pressure of the water and the relative humidity of the room. Without the cap, the water molecules at the surface of the ballpoint would gain enough kinetic energy from room temperature to break their liquid bonds and escape into the air as a gas. Within a matter of hours, the complex thixotropic gel would dry out, leaving a solid, immovable plug of polymer and pigment, blocking the tungsten carbide ball. By clicking the cap into place, you instantly halt the physics of evaporation, locking the remaining moisture in a tiny, perfectly pressurized microclimate. Notice how the faint scratching sound of your writing changes depending on the surface beneath your notebook. If your journal rests on a solid, dense oak table, the acoustic properties of the wood will amplify the vibration of the pen. Oak is a porous hardwood with a density of roughly 0.75 grams per cubic centimeter. The sound waves travel downward through the paper, strike the dense, cellular structure of the table, and resonate outward, creating a slightly deeper, hollow acoustic tone. Conversely, if your journal is resting softly on the thick fabric of a bedspread, the sound is entirely absorbed. The complex woven fibers of a blanket act as an acoustic dampener. The kinetic energy of the sound waves enters the trapped air pockets within the fabric and dissipates into microscopic amounts of thermal heat. In this environment, the act of journaling becomes near silent, an intimate, frictionless interaction between your mind and the page, perfectly suited for the quiet descent into the night. In this quiet space, the physical mechanics of the world, the friction, the light, the hygroscopic paper, and the olfactory chemistry, all align to support a single purpose. They provide a stable, perfectly engineered platform for your consciousness to rest upon. The universe is composed of swirling galaxies, violent stellar ignitions, and massive gravitational pulls. Yet here, at the tip of your pen, everything is ordered, predictable, and profoundly calm. You have mastered the physics of your immediate environment, turning raw materials and ambient light into a peaceful sanctuary. Trace the pathway of your final written thought as it permanently sets into the woven cellulose. The step-by-step process of ink drying is a quiet masterpiece of molecular physics. When the liquid first makes contact with the paper, the primary solvent, whether it is a water base or an alcohol compound, immediately begins to interact with the ambient air. Over the course of precisely 2 to 5 seconds, The thermal energy in the room excites the solvent molecules, causing them to evaporate and transition from a liquid state into an invisible gas. As this moisture departs, the heavy pigment particles are left behind. These particles physically bind to the paper fibers through microscopic van der Waals forces, forming an unbreakable permanent chemical lock. Your thoughts are now fully physically materialized. Observe the slow, deliberate motion of your hands as you bring the cover of the journal to a close. The flexible hinge that binds your pages together is heavily reliant on a specific aliphatic, rubbery synthetic polymer known as polyvinyl acetate, or PVA glue. The chemical formula for this remarkable adhesive is C4H6O2N. As you fold the book shut, the PVA glue flexes along its complex polymer chains, absorbing the mechanical stress and protecting the delicate sewn threads. The physical act of closing the heavy cover forcefully displaces the trapped air between the pages, pushing out the atmospheric pressure of 101.3 kilopascals in a soft, satisfying exhalation of paper. The day's record is sealed. Move your attention to the bedside lamp. The process of plunging the room into darkness happens with staggering quantum speed. If you are using a modern light-emitting diode, or LED bulb, clicking the switch severs the electrical circuit. Instantly, the continuous flow of electrons across the semiconductor band gap is halted, because the electrons no longer have the kinetic energy required to drop into the lower energy state. The photon emission drops entirely to zero in under 10 nanoseconds. The electromagnetic radiation ceases, and the room goes completely, perfectly black. Understand how your body immediately begins a step-by-step biological adaptation to this sudden darkness. Without photons striking the retina to suppress it, the complex biological machinery of the eye goes to work. The radial muscles embedded within your iris begin to slowly contract. Over the course of a few minutes, your pupil expands from a daylight diameter of just 2 millimeters up to a vast light-gathering aperture of 8 millimeters. Your eyes are mechanically dilating, opening themselves up to capture the faint, ancient starlight filtering through the window. Deep within the center of your brain, a profound chemical cascade is initiated by this very lack of light. The suprachiasmatic nucleus, a tiny region of the hypothalamus, continuously monitors optical input. When it detects the total absence of blue wavelength light, specifically the energetic photons vibrating between 460 and 480 nanometers, it sends a decisive electrical signal to the pineal gland. Step by step, the pineal gland begins to synthesize a hormone from the essential amino acid tryptophan. This newly forged molecule is melatonin. As it slowly releases into your bloodstream, it acts as a systemic messenger, traveling to every organ and tissue, gently instructing your biology that the time for wakeful processing has ended and the time for cellular repair has arrived. Feel the heavy, comforting transition taking place in your cardiovascular system. Your sinoatrial node, the natural biological pacemaker located in the upper right chamber of your heart, responds to the parasympathetic nervous system. It begins to lengthen the electrical pauses between each heartbeat. A waking active heart rate of 70 beats per minute smoothly decelerates, dropping down into a deeply restorative rhythm of 40 to 50 beats per minute. The rhythmic pumping of the blood becomes a slow, distant drumbeat, perfectly paced for the long journey of the night. Simultaneously, the thermoregulation of your body shifts gears. The blood vessels just beneath the surface of your skin undergo vasodilation, widening slightly to allow thermal energy to radiate outward into the cool air of the room. Through this deliberate process of heat displacement, your core body temperature slowly drops by precisely 0.5 to 1.0 degrees Celsius. This microscopic mathematical cooling is an absolute biological prerequisite for entering the deepest, most restorative stages of slow-wave sleep. Settle completely into the mattress and notice the gentle physical relief of your posture. By laying your body in a perfectly horizontal position, you neutralize the constant downward mechanical stress of walking and sitting. The Earth's gravitational pull of 9.8 meters per second squared is no longer compressing your spinal column. Instead, that gravitational force is now evenly distributed across the entire broad surface area of your back. The intervertebral discs between your spine are finally able to decompress, absorbing surrounding fluids and gently expanding in the comforting void of the dark room. Pay close attention to the shifting mechanics of your breathing. The tidal volume, the precise measurement of air you draw into your lungs with a single breath, begins to decrease in size, trading depth for a profound, unbroken consistency. The respiratory rate stabilizes, settling into an autonomic rhythm of 12 to 16 breaths per minute. You no longer have to consciously direct the air. The ancient brainstem has taken full control of the bellows, managing the exact ratio of oxygen and carbon dioxide your body requires. As you slip closer to the threshold of sleep, your brain initiates a vital safety protocol known as REM atonia. The brainstem actively secretes two powerful inhibitory neurotransmitters, gamma-aminobutyric acid, widely known as GABA, and glycine. These chemicals flood the neural pathways connecting to your spinal cord, systematically blocking the transmission of motor signals. Your skeletal muscles are gently, safely paralyzed, ensuring that you remain perfectly still while your mind travels across the vast landscapes of your dreams. You are anchored securely to the bed, wrapped in a heavy biological blanket of profound physical peace. Now, the brain begins its essential restorative night shift. A remarkable network called the glymphatic system activates. Step by step, the glial cells surrounding your neurons actually shrink in physical size, increasing the interstitial space within your brain tissue by up to 60%. This massive structural widening allows cerebrospinal fluid to flow freely through the neural pathways, efficiently sweeping away accumulated metabolic byproducts, such as amyloid beta proteins, that built up during your waking hours. It is a slow, methodical, deeply purifying flow of microscopic tides, refreshing the physical architecture of your mind. While this physical restoration occurs, an invisible electrical archiving process begins, perfectly mimicking the ritual of your journaling. Deep within the hippocampus, electrical bursts known as sharp wave ripples begin to oscillate at an incredibly fast frequency of 150 to 200 hertz. These high-frequency ripples are actively transferring the fragile, temporary memories of your day outward into the vast, folded landscape of the neocortex. Your brain is essentially writing its own internal journal, organizing, categorizing, and safely storing the data of your life into permanent, long-term memory. You are entirely composed of the cosmos. Astrophysicists have calculated that exactly 97% of the mass of the human body consists of stardust, elements forged in the fiery high-pressure cores of ancient collapsing stars through a process called stellar nucleosynthesis. The oxygen flowing through your newly stabilized breath, the carbon atoms that form your cellular walls, and the calcium carbonate fortifying your resting bones were all born in the deep, silent void of space, billions of years ago. You are not separate from the universe. You are the universe, momentarily folded into the shape of a human, lying in a bed, writing down its own history. As you rest in total stillness, the planet beneath you is in constant, majestic motion. The Earth is quietly rotating on its axis at a steady, mathematically perfect rate of 15 degrees every hour. You are currently being carried away from the sun, rotated deeply into the protective shadow of the planet. This massive conical shadow, known scientifically as the umbra, stretches outward for 1.4 million kilometers into the freezing vacuum of space. You are perfectly shielded from the solar wind and the harsh glare of the star, safely cocooned in the deep, dark quiet of the planetary night. Everything is complete. The physical ink has bound to the paper. The complex biological machinery of your body has slowed down, synchronized, and turned inward. The vast clockwork of the solar system is turning smoothly, safely holding your weight against the bed. There is nothing left to calculate, nothing left to document, and nothing left to carry. You are safe. The day is entirely finished. Your thoughts are secure. The universe holds you in perfect equilibrium. You are resting in the heavy, silent comfort of the void. Let the rhythm of your heart guide you downward. Let the slow orbit of the planet carry you into the deep. Surrender to the quiet physics of rest. You are a piece of the cosmos, returning to sleep. Good night.